for this document, we worked with Dave Becker at the Army Corps, but we wanted to get some broader perspective, so we actually solicited a lot of case studies. And so we went to both DOD and DOE and EPA and private industry, and we looked at case studies and had contributors to bring those forward. And we also asked them for comments on the document. And so that was very instructive because we actually had our first pass at it, and we got a lot of comments on, well, you need to think about these things. So I think it was really worthwhile for us to get out and have a broad review of this. So that's what it represents is, our go at trying to give a structured approach, input by this sort of broad base of reviewers, and then a lot of case studies to kind of explore some of those issues. And this is sort of a summary level flow sheet of what the assessment is like, and there will be a more detailed one that I show later, but it basically comes down to these key steps. First thing we talk about is, again, just like with SVE, you got to re-look at your conceptual site model because you've changed the system, right? You've run pump and treat for a period of time. You're going to learn some things from that, and you're going to perturb the system. So you need to gather that information, and then there's going to be a series of decisions that you're going to go through when you're looking at the data. And so, obviously you're going to look at whether or not you've met the remedial action objectives. But beyond that, some of the key elements you're going to look at are things like, well, during this pump and treat period, has my plume declined? In some cases it doesn't, right? But if it has, then you might ask the question, well, have I declined it enough that M&A will now meet my goals? Can I pull the plug on pump and treat and reach that? So there's sort of a line of evaluation you do to support that, and that may or may not be the case. So if your plume has not declined or you haven't declined it enough to meet M&A, then you've got a next set of decisions to make, and that's based around, do I continue pump and treat with optimization, or is there something that's sort of inhibiting the pump and treat fundamentally, and what is that and how do I address it? So do I have matrix diffusion that is going to be a problem no matter how much I optimize my pump and treat, and therefore am I going to have to address that in a different way? So you can kind of see we divide this into a couple different parts. Have I declined the plume and can I use M&A now, or plume hasn't declined, figure out why, and then either update your pump and treat system or supplement pump and treat or do something completely different. So that's the fundamental process in this document. And the idea was to put that out on the table because that's what you really need to focus your discussion on. What's the data tell us? Does it tell us M&A is close or not? Does it tell us we got a problem, and how can we articulate what that problem is? So in the document, the other thing we had to recognize is, this is sort of a cartoon of pump and treat, and we all know what that is. You extract contaminated groundwater or use hydraulic control. But in the document, we have to recognize that we apply pump and treat for different purposes. We may apply it to diminish a plume, to actually pull that plume down in size and concentration, or we may apply it just at the source for source control. Just put a line in the sand. I don't want the source to go beyond this, and then I can do something different with my down gradient plume. Or we may apply it for a plume containment. Same sort of idea. Do we put a line in the sand either at the very end of the plume or like at a property boundary, or maybe somewhere in the middle of the plume where you look at doing something different for that downstream bubble, maybe M&A or some other treatment. So in the document, we start out with talking about how pump treats are deployed, how you can kind of categorize them, and those are sorts of things along with the conceptual site model that you have to think about when you get to some of these decision elements. So we won't walk through all of that now, but I did want to let you know that that's in the document. And again, I think it's important because it all gets at this idea of having a basis for your conversation among the site parties, the regulators and the site owners. So here is the full decision logic that's in the document. And, I'm actually going to go through this element by element, or not every element, but I'm going to go portion by portion, so we'll kind of talk through this. But the key thing here is that what we kind of divided this up into is this idea that you're going to make decisions, and so you have decision elements, which are all those blue boxes. You're either going to get some information or you're going to make a specific decision, and then you're going to have different categories of outcomes. And we can't make this specific to a site, but we can say that your outcome is going to be one of certain different types of categories. So either you're going to decide to close the remedy, you're going to optimize the pump and treat, you're going to transition to M&A, you're going to supplement pump and treat, or you're going to transition to something new and not do pump and treat anymore. And the reason we kind of bend them in those ways is that if you remember back to that original flow sheet, that kind of is where you land as you answer some of those questions. And so the challenge is what information you need to have to get yourself into one of those categories, which may look different for a different site. So for instance, supplementing pump and treat at one site might mean doing bioremediation. At another site, it might be doing chemical oxidation. At another site, it might be a permeable reactive barrier. That we can't distinguish in this document, but we can lead you toward, well, that's what you're moving towards that category of remedy. So the decision elements are the things that we think that you need to have on the table to help you get to that type of outcome. So that gets down to your contaminant concentration and trends. And so in the document we talk about, well, how do you collect that data and how do you analyze trends and how do those support different decisions? Contaminant mass discharge is sort of our way of thinking about the strength of the plume. So, for SVE, we have the strength of the vadose source. For in the plume, we can categorize what our strength is, or our propensity for continued migration might be a way to think about that. So let's measure that. And then the attenuation capacity, of course, relates to our natural attenuation and what level of that we might be expecting. And no matter what we're doing in the plume, we have to quantify that, because that will either be all of our remedy as M&A or maybe some part of our remedy and relate to when we do our transition. Future plume behavior gets to the idea that if you're making a decision about pump and treat other than that you're shutting it down because you met your goals, your plume is going to do something, right? If you turn off the pump and treat or you modify the hydraulics of the system, the plume's going to move. And where's it going to go and what's it going to do and how does that relate to what your next step is? So this estimate of that future plume behavior is important. So that kind of folds into some of these decisions. And then the last piece is important in that because you designed a pump and treat system, or somebody did, and they had that as a certain basis, and you have certain operational data from that, what does that also tell you that's important in making your decision? And that could be as simple as just your cost-benefit analysis if you're comparing that in a feasibility study sort of mechanism with another transition approach, or it may give you some fundamental information to help you support some of these decision elements. So let's kind of walk through the decision logic and show you what that looks like. So the first part is to update your conceptual site model. And again, like the soil vapor extraction document, you need to do this to a level that you're comfortable with supporting your decisions. So this kind of gets down to have you characterized the site enough and to support the decisions you have to make. And the problem you have is, well, how much characterization is that? And that's why we tried to focus on some of these decision elements. So this portion kind of plays with the decision tree in that we know we need to know hydrology and flow conditions and plume characteristics and mass discharge and attenuation capacity. So what you need to do is think about how you're updating that conceptual model, knowing what sort of decisions you're going to make in the future. And that's that concept of decision elements. We don't need to know every little nit for characterization. We need to know these because this is what we're going to use to support a decision. So it's laying those out up front with the idea of the decisions to come. The first kind of set of decisions then are, have you met your remedial action objectives? That's, again, typically could be a fairly straightforward one, but we have to include that as an option. And then we get to this first big turning point, is your plume declined or not with pump and treat? And if it has declined, then really the question for natural attenuation is the remaining plume strength balanced by the amount of attenuation capacity that you have in your aquifer? And so how do you quantify plume strength? So we give you some tools and resources for that. And how do you quantify attenuation capacity? And we give you some tools and resources for that. And we'll have a couple examples in our case studies. Most of the time we're going to spend on case studies where we kind of talk about that. There's not one way to do either of those, but those are important things that we're doing. We're kind of doing this balancing act. And so that's what we get down to with this decision diamond is your contaminant mass discharge greater or less than your attenuation capacity? If it's less, well, then M&A may be a suitable transition. If it's not, then you need to think about other things. One of the things that's important in that decision, though, when you're looking at this balance between mass discharge and attenuation capacity, is again this idea that if you look at the left side of this diagram, when you apply pump and treat, you're going to have done some sort of hydraulic manipulation of that plume. You're going to be containing it no matter what. You've changed the hydraulics. And if you're going to turn this off and rely on some attenuation, you have to consider how much space do I have? Do I have no space before my receptor? Well, that's going to give you a different answer on what that characteristic needs to be. If you have some space where you know when you turn out the pump and treat, your plume's going to expand somewhat, but the attenuation capacity will stop that expansion, stabilize it, and eventually decrease it, that may be acceptable. But you have to think about it in this overall context, because you turn off those pumps and the plume will change. And so I think it's important in this document to recognize those plume dynamics and have everybody think about, well, is this going to be appropriate or not, given the setting for the receptors, and do I have an attenuation zone that I can functionally define for a site? So that's in the document, and I think, again, is an important but site-specific decision. We just bring up the question so people can talk about that and then give you some tools to make those calculations. So if we have gone through this first part where we looked at the plume and it really has not declined, or maybe there's a portion of it that's not declining very well, and we really haven't met this idea of being able to transition to M&A, sort of the first element of this would be to think about, can I just optimize my pump and treat system? I've got a sunk capital cost. Do I go ahead and optimize it, and is that possible? And that's kind of related to this next set, in that you really have to think about that in terms of what are the factors that were inhibiting my pump and treat remediation in the first place. So if you know that's coming, guess what? That's what you're going to have to be characterizing for or thinking about when you do your site conceptual model. So that's just how these things are related. So that's a key factor when you're looking at performance assessment, is saying, well, what is inhibiting my performance if it's not meeting some expectations? And so now we get into this dynamic of thinking about what are the factors inhibiting remediation, and how do I fix that? Do I optimize pump and treat, or do I switch to another remedy? So that's in a nutshell, the kind of flow of decisions that we think are appropriate for doing the performance assessment. And in this document, we go through those, go through that logic. We kind of talk about the type of data you need to support those. We have a big section on conceptual site model and some tools and some resources that you can gather that information, and then we talk about how you then apply and do some of these calculations where you, for instance, compare mass discharge and attenuation capacity. In the logic, it talks about the type of data you have. When you get down to that part of assessing the M&A, it points to doing the M&A evaluation per the EPA technical protocol, right? But what you've done is, the difference is, the protocol is written for a plume that you haven't perturbed. And the benefit of this document is saying, well, look, we've perturbed this plume. We know when we turn off these pumps, the plume's going to move. How do I collect data when I can't use those exact methods that are in the technical protocol and still convince myself that M&A will work? And then how am I going to verify that afterwards, realizing I'm going to turn off the pumps, the plume's going to move around, and now I can say, yeah, M&A is going to work based on these data. So that's the difference. You still have to abide by the OSWR guidance, for instance, but I think this is a way that you can negotiate with your regulators to say, here are some of the differences because I've got some pumps working at the site. Does that make sense?
Right.